Okay, here we are back again. This is section 5.4. I think you'll find 5.4 is going to be an easy one for you. And it'll be good for you to get 5.4 out of the way when we go to 5.5. I'm not sure the material is all that much harder, but there's more of it there. So it would be good for you to get this section done. So when you get a chance to start 5.5, you can get that done in a timely manner. Okay, there is a thing in mathematics called the multiplication principle. And simply put, if there are m ways of doing one task and n ways of doing a second task, then there are m times n ways of completing both tasks. Now, after I show you an example, that'll make 100% sense to you. And this is what we call counting. We're coming up with different ways of counting the number of possibilities. Okay, here's the introduction I got. So let's say you have 3 different pairs of pants and you got 4 different shirts that you can choose from. So how many outfits do you have? 3 pairs of pants, 4 different shirts. So let's try to put a picture to this. So let's say the pants, you've got brown, blue, and gray. There's your 3 colors. And for the shirts, you've got these 4 colors: white, pink, green, and red. So the idea is we're going to match each of these with each of those. So if I start out with a blue pair of pants, I could go blue with a white shirt. I could go blue with a pink shirt, blue with a green shirt, and blue with a red shirt. When I go to the brown pants, I could have brown and white, brown and pink, brown and green, brown and red. And for the gray pants, I've got gray and white, gray and pink, gray and green, gray and red. You get the idea. So if you counted up all these different possibilities, there should be 12 of them. Well, if you notice as I put them down, we had 4 rows and we had 3 columns. So the idea is if there's 12 altogether, it might have been easier to just take 3 times 4. So there's 3 ways of picking the pants. There's 4 ways of picking the shirt. Going back up here to our definitions, there were 3 ways of doing the first task, and there are 4 ways of doing the second task. So to find how many different possibilities I had, I took 3 times 4. That's what I'm showing you here. I don't necessarily want to write all of those things out. I'd rather just take the numbers and multiply them and be done with it. And that's what you call using the multiplication principle. Okay, here's another example. Let's say that we got 3 roads connect town A to B. So I got town A right here, I got town B, and I got town C. So you'll notice I've drawn this, so I've got 3 ways of going from A to B. And we're all going one direction. We're not even looking about coming back. And then from B to C, we've got 2. So the question is, how many ways do we actually have of starting at A and ending at C? Well, you had 3 ways of doing that task, and you got 2 ways of doing that task. 3 times 2 is 6. See, I told you these were easy. Example 2, menu choices. Diners at Angelo's Spaghetti Bar can select an entree from 6 varieties, so that number is important. 6 varieties of pasta and 28 choices of meat sauce. So how many combinations are there? So the first task, you have 6 possibilities. And for the second one, we have 28 ways of doing that one. So all I'm going to do is multiply those together, and I believe you come up with 168 ways of achieving your goal. Now, granted, just like the pants and the shirt, there might be some of those combinations would be desirable and some may not, but that's beside the point. We're trying to figure out how many possible there are. And this is something that will come up when we get to probability in chapter 6. Okay, Let me do this. I'll move that. See, I'm bleeding through a little bit with my marker. Example 3. A coin is tossed 3 times, and the sequence of heads and tails are recorded. How many different outcomes are there? Well, the simple thing is, when I tossed the coin the first time, 2 different things could happen. When I toss the coin the second time, 2 different things could happen. And when I toss the coin the third time, 2 different things are going to happen. The 2 things are always heads and tails. So on the first toss, I could get heads or tails. On the second one, I get heads or tails. And on the third one, I get heads or tails. 2 times 2 times 2 is equal to 8. Now, sometimes you'll need to keep yourself organized, even if it's just mental. But you could draw yourself a picture, and this is called a tree diagram. And I know you've done this before. But when we toss the coin the first time, I could get heads or I could get tails. That represents the first toss. Now, if you got heads the first time, you're going to flip it again. Same thing with tails. And on each of these, you could get heads or tails here. You could get heads or tails here. And that represents the second toss. We're doing it 3 times. So imagine if I got heads on the first one, heads the second, I'm going to flip again, heads or tails. So this would be the third toss. Down here, heads or tails. Down here, heads or tails. Down here, heads or tails. No matter what you got on the first 2, you still have a chance of heads or tails on the last one. Now I'm going to show you one more thing, and these are called outcomes. I already know there's 8 of them. But what are they? Well, if I started here and followed the branches of the tree, I could get heads, heads, and heads. That means heads on the first, heads on the second, heads on the third. Or to get to this tails, I would have went heads, heads, and then tails. So H, H, T is the second outcome. Your third outcome, how did I get here? Heads, tails, heads. This one will be heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. Most of the time, you don't have to come up with all the different outcomes. You just need to know how many. That's what this section does. It wants to know how many outcomes you're going to have. Okay, we're going to go down to this one. A combination lock. Most of you guys have had locks when you're in high school. And when you do it, usually there's 3 numbers involved. And what I usually do is draw blanks. So a combination lock is unlocked by dialing a sequence of numbers, first to the left, then to the right, and then to the left again. So if there are 10 digits on the dial, how many possible combinations are there? So if you think of the spaces, on the first one, there's 10 digits, so you have 10 possibilities. Okay? On the second one, you're going to have 10. And the third one, you're going to have 10. 10 times 10 times 10 would be 1,000. 1,000 different combinations that are possible. That would be important if you were at the administrative school. You want to make sure you've got enough locks out there, enough combinations to satisfy everybody. Okay? Let's look at the next one. I still got 3 numbers. This says, what if you can't repeat the first one? Well, the first one, there's still 10 possibilities. Could be any one of them. But as soon as you pick one, that means you're going to have 1 less. So there's only 9 for the next one. And then 8. Because this one can't be either one of the first 2. So 10 times 8 times, be what, 720 different combination locks you could have. Okay? And you know, on this one I said, well, there were 10 digits? What if there were 20? And what if there was 30? Most of the high school locks had 30. So that would have been 30 times 30 times 30. Or if they can't repeat, it would have been 30 and 29 and 28, whatever those would be. More than enough. Okay, let's move on. I hope you're reading these in the outlines I've been posting on ACE by looking them over. At least I don't have to read through all these words. Okay, trying to be swift about it, though. An investor has decided to purchase shares of stocks of 3 companies, one engaged in aerospace, one involved with energy, and one involved with electronics. After some research, the account executive of a brokerage firm has recommended that the investor consider stock from 5 aerospace companies, 3 energy companies, and 4 electronics companies. So how many ways can we invest our money? Going back to this 3 right up here, that tells us we're going to have 3 blanks. And the first blank, that's for aerospace. There was 5 aerospace companies. There was 3 energy companies and 4 electronics companies. So all you're going to do is take 5 times 3 times 4. The problem itself isn't hard. You've just got to be able to dig out the numbers. So 5 times 3 is 15, and 15 times 4, that number is going to be 60 for the answer. Okay, last one. Tom's planning on leaving for New York City from Washington, D.C. on Monday morning and has to decide that he will either fly or take a train. There's 5 flights and 2 trains leaving that morning. When he returns Sunday afternoon, Tom's either fly or hitch a ride with a friend. There's 2 flights. And of course, she's got coming home with a friend. So basically, we're going to start at Washington and we're going to go to New York City. How many different ways do you have of going there? And then on the return trip, we're coming back to Washington. Well, going from here to here, there was 5 flights and 2 trains. So you have 5 up here, 2 here. That's a total of 7. I got 7 ways of going from Washington to New York City. When he returns Sunday afternoon, Tom's planned to either fly or hitch a ride with a friend. There's 2 flights. So coming back, there's 2 flights. Or hitching a ride with a friend. We assume there's only one friend. If you had more than one friend, then that'd have to be given to you. But 2 up here, 1 down here, that's a total of 3. 7 times 3, the answer is going to be 21. Okay. Now, I'm going to throw some more examples in here. For example, telephone numbers. When you have a telephone number, you usually have a zip code, followed by 3 numbers, followed by, can't get them all in there, followed by 4 numbers. So how many different telephone numbers are there? Well, each of these blanks could have any number 1 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different possibilities. You could have 10 here. You have 10 here. And going across each of those are going to be 10. They're all 10s. How many 10s do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them, so the answer is 10 to the 10th. So you go 1, 2, 3. 1, 2, 3. 1, 2, 3. That's 9 zeros, 10 zeros. There you go. That's 10 billion telephone numbers. But of course, that's not all true. Those area codes are for the United States. Then each country will have a special code. Like if you wanted to dial something outside the United States, then you got to put another number out here. Usually that starts with a 9. Now, this is not a truly accurate example because there's not 10 different possibilities you put here. You can't put a 0, and I don't think you can put a 1. But there's limitations. But if there were no limitations, that's what you would have. Okay? Now, I bring that up because somebody at the telephone company's got to figure out if they got enough phone numbers out there. When they start running out of phone numbers, then somebody's got to do some planning. I always like to use the example when you guys probably know the show Mayberry, Andy Griffith, Barney, and all those guys. Mayberry was a small town. Back when that was filmed, if you can imagine all those telephone numbers fed into one place. And let's just say there's 10 lines coming out of that. Well, back then you might have Barney over here, and he was always wanting to call Juanita down at the bar, at the diner. I don't know what Thelma Lou was thinking. But what Barney would do is he would pick up the phone, which sent a little current through the line, and this is the operator. So if you can imagine, this is usually at somebody's house. It was like a part-time job, but when it'd ring a bell, whenever it rang a bell, that person would have to come over, and they'd pick up a line, talk to Barney, and Barney'd say, connect me with Juanita. So what she would do is connect the route, and she'd take a wire and connect it from here, and then over to here, and then it would ring at Juanita's. So you had 10 different numbers. Well, later on, they might have said, okay, M for Mayberry, and maybe this was the number 7. So then she had a telephone number of M7. And if I wanted to go to a different town, let's say I wanted to call Raleigh, that was another town in there, then maybe they would give these guys numbers. So 1 might have been Mayberry, and 2 was Raleigh, and 3 may have been Asheville, and is in North Carolina, so you can just come up with all those. These later became area codes. Now, just to give you an example, when I grew up, and some of you guys might remember this, but as I remember, my telephone number was this. And I lived in the area of UIndy. It was State 72328. Later on, they abbreviated that. Of course, that became State 72328. Okay. State was some sort of word or something, like up here, when I was saying M, that was for Mayberry. So M stood for something. Okay. ST stood for state. And what did state stand for? Well, the operator at that time, her home was up on State Street, which is over by the football stadium. So that's why they called it State. In Marion County, I can tell you this, Marion County, it's where the school's at, is broken up into 9 townships. Some of you guys know that. Some of you not from here probably don't. But basically on the south side of Indy, that's where the state numbers were from. When you went down in here farther, it was Tucker. I think that was the last name. If you were downtown, it was Melrose. If you came over to the east side, it was Fleetwood. And I don't remember all of them. I know over here was Ben Davis because there used to be a town of Ben Davis. So anyway, that's where they came up with those. So later on, they decided they didn't want to use ST. So if you look at a phone, on there you've got some letters with each of the numbers. And an S was on the 7 and the T was on the 8, so it became or 787 instead of state 7 became 787, and then 2328. If you look at the numbers at the university, they're all 788 numbers. And at one time, the switchboard, if you remember this word, that would connect you with the main switchboard at the university. They did that on purpose. And then every 788 number was an extension on campus. So that's where they came from. And by the way, I was talking about going back to this. So my number was, I'm going to put state 7, but I'll just call it 787. When I was young, the only two numbers were 786 and 787. I remember it was a big deal. They added 784. And then later it was 782 and 783 and 789, and it went on and on. But each of those was, you could locate where the number came from by the way it was coded in. Can't do that anymore. With cell phones and fax numbers, everything exploded, so you can't do that. Here's one last thing I'm going to put out there. And the reason I bring that up is because somebody at the phone company's got to make sure they got enough phone numbers. So let's go to this. Most license plates today have 3 letters and 3 numbers. So if you want to know how many different license plates you could have, well, for the letters, there's 26. So 26, 26, and 26 for each of those letters. And 10, 10, and 10. So if you multiply all that out, that gives you a really long number. And that's nice to know. It wasn't that long ago in Indiana, the license plates were like this. And I'm showing you this because what happened is, let's go back to here. So a license number looked like this. You had a number here, and in this area it was usually 49. And then you had a letter here, and then 4 numbers. Well, as it worked out, I'll start with the middle. P was for Perry Township. So if you lived in Perry Township, that's where you went to get your license plate. The 49 was the county. And then those numbers were all the different things you could have. So at the time, there were 92 counties. You're going to say, well, you got 2 spaces, it should be 10 times 10, but they didn't use all of them. There was 92 counties in Indiana. And then you could say there was 26 letters, but back then there may have been, well, there was 9 of them. If you go back to my picture on this one, remember how I said there was 9 townships? Each township had a license break, so there's 9 of them. So realistically, there was only 9. And then you had 10 times 10 times 10 times 10. Well, what happened, they did that for a long time. And that's a really big number if you multiply it out. But what would happen is they'd run out of license plates. 49 was Marion because it was 49th alphabetically. So Marion County was the largest county, population-wise, in the state. So what would happen? It would run out. Well, I told you there was 92 counties, so their thought was, okay, we're going to start putting out 93s. So if you lived in Marion County, you could have either a 49 or a 93. So that took care of the problem for Marion County because it doubled the number of license plates. Well, okay, so 93 is taken care of, and I may not have the order correctly here, but I think 94 is like Lake County, it would run out. So they gave them a number. And I think 95 was right next to Lake, it was Porter County. And let's say Fort Wayne was 96, and Evansville was 97, and let's say 98 was South Bend. And then 99 went back to Indy because they ran out again. So if you had 49 or 93 or 99, any of those could have been Marion County. Well, now what happens if somebody runs out of license plates? They had to come up with something else. Well, they did several things. One of the things was if you had a truck, you got a special license plate, it's different from a car. And it usually says truck on there. And then, matter of fact, they came up with several different things for trucks. You could have had like a smaller truck or a larger truck, and then they went commercial trucks. Okay, and then they have like a van, and I don't. There's just all kinds of things. So they diversified the type of plate you could get. Then they went back and for the license plates, and California and New York has done this for years. But now we're back to this. So for the cars, you got the 3 letters followed by 3 numbers. And that's the way it is today. Oh, and something else they did, they have specialty plates. Perhaps you have a specialty. Like, for example, let's say you could have a U-Indy license plate. So it's got a UI on the left of your license plate. And I know there's several thousand people that have those. Well, that takes a drain off the other plate. So that's a diversification. Any of your colleges, Butler, IU, Purdue, they've got specialty plates. You've got other things. I know there's one for pets. I know there's one for teachers. All those were attempts to diversify your license plate so they could print enough. Now, the 2 examples I gave you for phone numbers as well as license plates, the reason I gave those to you was for one reason. I want you to understand that somebody's got to plan out how many of these you're going to have to produce, whether it's phone numbers, license plates, wardrobes. We start off with that in the intro. You got to have enough wardrobes for work, all kinds of things. Well, somebody's got to be able to count, and that's what we're doing here. Somebody gets paid to make these decisions, believe it or not. And by studying this, now you're qualified to take that job if you wanted to. Anyway, that's section 5.4. That's all of it. There is no part 2. So next time I see you will be in section 5.5. And it'll be a little bit longer.